guys, how are you? So in today's session we are going to talk about the hierarchical clustering. Hierarchical clustering is comes under the unsupervised technique where we make some clusters like in the field of data science, data analytics, machine learning, deep learning and artificial intelligence. When you get some data and you have to make some clusters, like if you get the data of population and you have to make the clusters for that population, then this hierarchical clustering algorithm is useful for you to make the clusters from that data. So let's start with this. And HCA, the short form or acronym for this hierarchical algorithm, this hierarchical clustering algorithm, we can also say that HCA is a HCA is a strategy that seeks to build a hierarchy of clusters that has an established ordering from top to bottom. K means would not fall under this category as it does not output clusters in hierarchy. So let's get an idea of what we want to end up with when running one of these algorithms. A hierarchy of clusters is useful, represented by a dendrogram shown below. So this hierarchy of clusters make a hierarchy in its backend while it is making and clusters. So it makes an dendrogram. It is also makes an dendrogram, which is look like this. This is like a dendrogram, and it is established ordering from top to bottom approach. So next is hierarchical clustering technique. Hierarchical clustering is one of the popular and easy to understand clustering technique. This clustering technique is divided into two types: agglomerative and divisive. Divisive, and these are the two types in which the hierarchical clustering technique is divided. Agglomerative hierarchical clustering technique. In this technique, initially each data point is considered as an individual technique cluster. So in this technique, first of all, we consider that every single point is a single cluster. At each iteration, the similar cluster merge with other clusters until the cluster or k clusters are formed. So basically, it combines the similar clusters with other clusters until the required number of clusters are formed. The basic algorithm of agglomerative is straightforward. Compute the proximity matrix. Let each data point be a cluster. Repeat merge two closest clusters and update the proximity matrix until only a single cluster remains. So the algorithm is like, you consider every single point as a single cluster, then you combine the two most nearest clusters, and after that you update your matrix, and now again you combine the two most closest clusters, and now you update a matrix, and you do and repeat these steps until you consider the whole until you consider the whole all points as a single clusters. And next is the key operation is the con- computation of the proximity of two clusters. The To understand better, let's see a pictorial representation of agglomerative hierarchical clustering technique. Let's say we have six data points A, B, C, D, and E. So here I am going to show you that pictorial representative of agglomerative hierarchical clustering technique. And let's say we have six points A, B, C, D, and A, B, C, D, E, and F. Step 1, the initial step, we calculate the proximity of individual points and consider all the 6 points as individual clusters as shown in the image below. So as you can see below, we consider every single point as a single cluster, and then we are going to combine two nearest point. B and C are two nearest point, then we consider as a single cluster. B and C, D and E are two similar points, two nearest closest clusters, then we combine. And after that we see that D, E and F clusters are close to each other, then we combine these two, and we go on to repeat these steps, and until we get until we get every point as a single cluster. So next, step 2, similar clusters are merged together and formed as a single cluster. Let's consider B, C, and D, E are similar cluster that are merged in step 2. Now we are left with four clusters, which are A, B, C, D, F. Step 3, we again calculate the proximity of new clusters and merge the similar clusters to form new clusters A, BC, DEF. Step 4, calculate the proximity of new clusters. The clusters DEF and BC are similar and merge together to form a new cluster. We are now left with two clusters A, B, C, D, E, F. Finally all the clusters are merged together and form a single cluster. So that's how this hierarchical clustering technique is performed. And the hierarchical clustering technique can be visualized using a dendrogram. A dendrogram is a tree-like diagram that records the sequences of merge and or split. So that's how we combine B or C, we combine B or C, then we combine D and E, then we combine D and E with F, then we combine these two, and then we combine whole data set, and we get a single cluster for the whole data points. And also in this Venn diagram or format, like in a diagram format, we can make it like this. So this is our dendrogram, and this is a diagrammatic represent of this hierarchical clustering technique. Next is divisive hierarchical clustering technique. Since the divisive hierarchical clustering technique is not much used in the real world, I give a brief of divisive hierarchical clustering technique. In simple words, we can say that the divisive hierarchical clustering is exactly the opposite of the agglomerative hierarchical clustering technique. In divisive hierarchical clustering, we consider all the data points as a single cluster, and in each iteration we separate the data points from the cluster which are not similar. Each data point will be separated, is considered as an individual cluster. In the end, we will be left with n clusters, as we are dividing the single clusters into n clusters. It is named as diffusive hierarchical clustering technique. So basically we consider all the data points as a single cluster, and we divide and we keep on dividing the single clusters single cluster into the n number of cluster by some criteria like the distance between them, and we keep on dividing the clusters till we get the n number of clusters. So this is a pictorial way, like we have 4 points, and we consider whole 4 points as a single cluster, and if we want the four clusters from these 4 points, then we point every then we make every point as a single cluster then we make every point as a single cluster, and here we get a four clusters from these whole dataset points. So that's how this divisive hierarchical clustering technique is work. And so that's all for the theoretical session, where we talk about the hierarchical clustering, how it is work, how it make the hierarchy in its backend, and the agglomerative hierarchical clustering technique, and the divisive hierarchical clustering technique, and how they work. And now we go and move on to the coding session, where I'm going to tell you that how you can see this dendrogram, and how you implement this hierarchical clustering technique implemented in the Python.